All right, let's try to do this. Like to show you like how we can achieve this left hand side right hand side equivalency. So we start with this, right, xy, and then we can write it down from here, x and 1 or y. So and is distributed over or, and which is basically x and y by identity equals x, right? And how about this one? This is the same thing. X and x or y equals, basically what we'll do here is, so usual tendency is to do this, right? Distribute and over or, right, which is x or xy, which is x from 1, right? X or xy is x. Now here xy or xy bar, we can write it down as x, y or y bar equals x and y, x and y 1, which is y plus y bar is 1, x. This one is similar, x, y and x, y bar, which I can do like this, x plus y, y bar, right, by identity distribution of or, and then it becomes x or 0, which is x, and this one is x or x bar y is, you are distributing x or this OR operation over and, this is x or x bar is 1 or x plus y equals x plus y. And number 6, x bar, we're distributing and over or, so it becomes x bar or x y, which is equals x and x bar is always 0 or x and y, let's write xy equals xy. So that saves it. Sorry, that's basically proves it that we can make this 6 relation. We can always derive it using basic identities, but they're so commonly used. If you see in a Boolean expression reduction problem, you can directly write from one step to another.